So today we're going to look at the HUD class and how you can use that class to sort of rectangle select objects like you can in the editor. So basically that old-fashioned approach like this. So what is the HUD class? Well, the HUD class is a class that's available in Unreal, and it essentially gives you access to a canvas that you can draw on. So you can draw boxes, or you can draw text or textures. And if you go to, say, your world settings into a game mode, you notice that one of the options, pawn classes, there is a HUD class here. So how do you create a HUD class, first of all? So if you right click, go to Blueprint, and you type in HUD, you get access to the HUD class. And as it says, it's a base class heads-up display, which is a canvas and a debug canvas on which primitives can be drawn. So if we click on that, select, and call that our BP HUD tutorial. So we want to set it. So first of all, we'll need a game mode and a player controller. So let's create one of those. So game mode, HUD tutorial, and a player controller. If we double click our game mode, now we can start setting some of our requirements. So particularly the HUD class, we can say that's our HUD tutorial. Our player controller can be our player controller HUD tutorial. And we'll change our default pawn to just the spectator pawn. Compile that. And here on the world settings, we can set the game mode. So we'll set that to be our HUD tutorial. And that will populate all of our HUD classes and player controllers for us. So let's open up our HUD. So double click on the BP HUD tutorial. And it just looks like any other Unreal class. But in the HUD, in the function overrides, you have access to this receive draw HUD, which allows you to do custom HUD drawing, like the pop-up says. So if we click on that, so what can you draw on a HUD? Well, if you type in draw, then under the HUD, you can see you can draw lines, materials, rectangles, text, even textures on there. So just a simple example, say we want to draw a text on there, and we wanted to draw it where the mouse is positioned. We could say get player controller, and we can say get mouse position. Then we can put the X and the Y there. We can maybe just write Unreal as our text. We can give it a scale. We can give it a font. And what should happen is, when we play, wherever we move our mouse, this will get drawn on the canvas and refreshed every frame. So if you're trying to do some debug, for instance, perhaps you want to know what the mouse is hovering over, you could just, again from the player controller, say under cursor get hit result by channel. We can break the hit result. We can branch. And just connect the hit actor name into the text. And so we get the name of the actor that our mouse is hovering over. So we want to draw a rectangle. So let's go back to our HUD. And we can probably get rid of this. We don't need it. What we want to use is the draw rect. So that will draw a rectangle on the screen, and it needs an X and a Y, which we can get from our mouse position, and then we need to calculate the width and the height of that rectangle. We should probably turn this into a function to make it more usable. So we'll open that, say get mouse position. We'll get that from the player controller, and we'll send back some of these results. So we'll send back the location X, the location Y, and we'll also send back a combination of the two as a vector 2D. So that will be a vector 2D. And we can just split that. And we can make that a pure function. So we can drag this out here, put our X and our Y. And now to calculate the width and the height of a rectangle, we'll need to know the two things. We need to know what the starting position is and what the end position is. So actually that shouldn't go there. We don't have access to any inputs in this class, so we'll need to use our player controller class for that, and then send that information across to the HUD. So if we open our player controller, and the way we'll do this is we'll do it on the left mouse button. So when we click the left mouse button, that will be the start location for the rectangle, and then we can drag it. So if we right click and say, we'll just do a debug left mouse button down. So when it's pressed, we want to send a message to our HUD. Now we can get the HUD here, so that's quite nice, it's already built in, but the best way to send a message would be via an interface. So if we create our first interface, blueprint interface, BPI HUD tutorial, and we'll have two messages. So one will be start drawing rectangle, and the other one will be stop drawing rectangle. We'll save that. Then on our player controller, on the HUD, we can just call start drawing rectangle. So when we press the left button, we'll send the start drawing rectangle, and when we release the button, we'll send the stop drawing on the BPI HUD tutorial. So that information will go across to our HUD. Now how do we accept that information here? So we'll need to go to the class settings, go to the implemented interfaces, or we can look for our BPI HUD tutorial. That will give us these two interfaces. So we do the start first. What we need to do is we want to draw the rectangle from where the point at which we click on the screen before we start dragging. So when we get the start, we'll store that location, and that location will be the mouse position. So we can get that, and we can just promote this to a variable, say start rectangle location. We should also set a boolean to tell the HUD that we are drawing at this point. So if we create a variable, say b is drawing selection, we can set that to true, then set the location at which it starts, and on the stop drawing we can set the is drawing to false. So now this will be the start. So first of all we branch to make sure that we are drawing, and that will be on this boolean that we just set. If we are, then we want to know the start location. And get that, we can split it. That will be the x, that will be the y. And then to work out the width and the height, if we know where our mouse has moved and we minus where we began, that will give us the x and the y, the width and the height. So get the mouse position where we are, do a subtract, and we take away the starting location which we set. Split that, so x will be width and y will be height. We can change the color of the rectangle, so say we want it to be like a greenish color. We want it to be see-through, so we'll reduce the alpha to say 0.35. And if that works, we should be able to draw a selection. So as I drag it, now we're not seeing the mouse cursor, are we? So let's go and set that in the HUD. So here we can just say set show mouse cursor to true. So wherever I drag the mouse, we'll get this box. So this rectangle will appear on the screen. Now we need a way to tell it to select everything that is within the boundary or overlapping the selection rectangle. So if we go back to our HUD again, there is a node in here which is very helpful, and that is the get actors in selection rectangle. And you give it a first point and a second point, and that will define its rectangle size. We can turn off non-colliding because we only want stuff that does collide in most cases. And we can set a class filter here, so we only get objects of a certain class. Now these are, I've just created, they're just a static mesh actor called a cube actors. So we can set that as our class. Now we need the first point and the second point. Well, we know that the first point is where is the start location, and we know that the second point will be where the mouse is located. So that's where our vector 2D is helpful. This will now give us an array of all actors overlapping that box. So we could just do a for each loop here. And we could just say print out the name of each actor. So if we play, once we overlap, we get one actor there, then we get 5 and 6, and now we're getting all 6 actors. So we want to be able to send a message to each of these actors to tell them whether they've been selected or not selected based on the selection rectangle. So again, the best thing would be to set up another interface. So we'll do blueprint interface, BPI, selection. And in that interface we can send them a message, tell them is selected or not, and we can send them a boolean to say whether they've been selected. So if true, they've been selected; if false, they're unselected. We then just open our cube actor that we're using, and there's two things. So one, there is a cube actor which has the static mesh, and I've also just added a decal to it. If I double click on that, so it's just a simple decal which will create a circular image at the base. So I've created a video on creating decals, so I'll link that in the right corner, and all of this is covered in that, so it's worth looking if you're unsure how to do it. But basically this decal is hidden when the game starts, visible is hidden, and then when we get the interface call we can then show it. So if we add the interface to the cube actor, DPI, so our selection tutorial, we get this event that will come through, and then based on the event we can decide whether to show the decal or not. So we can say set visibility, and that will be the visibility. Then in the HUD, from each of these we can just call the is selected or not message, and in this case we'll send true to begin with. Hook that up, and let's see if that connects correctly. So as I overlap, they start showing their decal. Obviously when I unoverlap, it's not disappearing, so that requires a bit more work. So we'll need to create some arrays. One, we'll need to keep a record of the actors that have been selected, and two, a record just of the actors we have just selected each frame. So if we promote that maybe to a variable, and these are the sort of newly selected actors. We'll need another one where we're storing the ones that have been selected at the end of each frame. So we can just duplicate this and just call that selected actors. And now we'll need to start looping through those. So with the newly selected actors, we'll compare them to the ones that we're already selected, and anything that isn't in the selected actors we'll need to select. So when we loop through this, we'll check in our selected actors. We'll say selected actors, do you contain this item? Then we can branch on that. If you contain it, it means we've already selected and we don't need to reselect. But if it's false, we'll have to select that actor. Secondly, we'll need to make sure that all the actors in the selected actors are also in the newly selected actors. So we'll need to do this almost in reverse. So we'll do another, at the end of this, another for each loop. This time we'll go through the selected actors and we'll compare it to the newly selected actors. So does the newly selected actors contain what was selected in the last frame? Does it contain the item? We branch. And if it doesn't contain the item, we need to unselect this. So we can come here and say is selected or not, and this time we do false. So if it doesn't, it means it's false, we do that. And then at the end of it, we need to set the newly selected to be the selected. So we get the selected actors, we set, and we just put that there. So we've now got updated our selected actors. We have a check of that. So if we play, and now when we overlap, we select, and we unselect when we're not. It remains selected at the end, but if you click anywhere else, it will unselect. What you might want to do in a game is once you've selected them, the next click might be the location to where you want them to move or to perform some task. But whichever way we do it, so now we've got the select and unselect. And basically once it overlaps, it selects. So that's working. So in this selection rectangle node, there is an option to must be fully enclosed. Now if you tick that, there is a problem. Now if I just show you, on the Mac I think there is a bug, but if you notice it selects it regardless of whether it's fully enclosing the rectangle or not. This used to work in previous versions, so this might just be a bug in the Mac, but it's okay in Windows. Now there is a workaround for the fully enclosed actors only approach, but that does require you having to do a fair amount of work yourself. So in essence here what I'm doing is, now we're fully enclosed, it picks it, and when it's not enclosed, it unselects it. And what I'm doing is I'm calculating the points of each of the corners of the bounding box, and then comparing, then checking to see whether they're enclosed within the rectangle. So basically, if you click on the show here, go to advanced, to any actor, you can see its bounding box. So there's a sphere bounding box, bounds, and that red is the sort of cube bounds. And from there you can sort of do a number of things. So in some of these functions I've got an is fully overlapped function, and here we look for all the corners of that bounding box. And the way we do it is from the actor we say get the actor's bounds. That gives us the origin and the extent. The origin of the bounding box is actually the center point, and the extents are from the center point to the edge. So if it's 100 centimeters across in the x, the extents will be 50 in the x, and if it's 200 in the y, the extents will be 100 in the y. So using that, you can then calculate the positions of all of the corner points, and then I've just drawn them there to make them visible. And then once I have sort of 8 points, 1, 2, 3, 4, 5, up to 8, and the way you calculate them is you take the center point, you take the extents, and from the center point, if you add x in one direction and then y in one direction, negative y in another direction, add the z, and so on, and reverse that, you'll end up with all 8 points, just with mathematics. Those 3D points, if you click here, then use this node, project world to screen. So it takes a 3D vector 3D, and it turns it into a 2D screen position. And that value that comes back, I then check to make sure it's in the range of the first point and the second point, x and y vectors. And if all of the points are enclosed, then we say that it's fully enclosed. So it's a bit of a workaround, and it can be a bit finicky trying to get it perfect. But if that node isn't working for you and you need that approach, that's one way of doing it. So I hope this explains the HUD class and how you can put debug text on the screen, or how you can rectangle select. You probably won't use it much because of UMG widgets, but it is a useful class to know about.